Okay. I guess I'll go ahead and present my screen. William, okay. Good thing I saw you. William's in here. Share. All right, so Jonathan's here. Okay. So, William, if you could just unmute for a second and just obviously let me know if you can see my Google Classroom really quick, William. Can everyone see it, William?
I can see it.
Sweet. Okay. So let's dive right in, okay, people? Let me write down Jonathan. Jonathan. Okay. So first of all, really quick, I just want to give a reminder. So the Wednesday thing, right? Unit 1 test assigned Wednesday, and then actually, when did I assign this? I don't know. I guess Wednesday. Yeah, like maybe Wednesday morning. Anyway. So, only one person has turned this in, which again, it's technically not due until tonight. But if you're trying to not wait until the very last second, or even like turn in things late, I would have liked to have seen more people have this done by now, because we're kind of moving on to Unit 2. But you definitely, again, like especially these things like tests, you don't want to turn in late, and lose points. These are the most important points, the most heavily weighted points there are, like in the test category. So if you're having any like technical difficulties or just any difficulties at all, you got to let me know. This is just a Google Doc, and you're filling in the Google Doc and you're highlighting things and turning them blue, and just so it's pretty simple and user friendly to do. So get this done. I don't want to have to take off late points on a test, because they're such important points. And only one person has done this by now. But we're moving on to Unit 2. So can you make sure, please, I'll give you a few seconds before I get rocking here, but 2.1, using variables, we're going to kind of blast through this really quick. And that should be it. I don't know if Mrs. Milano has a meeting. I don't think she probably doesn't, but we're going to try to blast through 2.1. So get this paper out while I just double check to see if anyone else has joined. Shouldn't be joining in late, but how do I do this? Right here. Oh, see, Hannah's here. Okay, good thing. Let's try to have everyone here on time. So, hey, please let me know some way, somehow. Speak up, comment, email me, something. All I know that's here is Connor, Allison, Dakaya, Aaron, William, John, and Hannah. That's all otherwise I'll mark you absent kind of thing. But let me know if you're in the room. Or in the future, if you join in late for some reason, you shouldn't be joining in late, but I might not catch you. So let me know that you joined in late. Anyway, here we go. Without any further ado. Using variables. So Unit 2 overall is about polynomials. Obviously that'll come clear as we go, but Section 2.1 is called Using Variables. What the heck is a variable? You probably know what a variable is all about. A variable is a letter, or like any symbol really, but I mean, we pretty much always use letters. Even if they're like Greek letters, we still use letters, you know what I mean? But a letter that represents one or more numbers. If I can elaborate on that for a couple seconds, listen to this. I bet you could think about it if I asked you to, and how sometimes a variable only represents one thing. When you're solving an equation for a variable, that's when it is only supposed to represent, one number, right? But a variable can totally be used to represent more than one number. A variable can be an open-ended thing, where like your variable can in theory be any number you want, you know what I mean? But that's a variable, it's just like a letter. Now an algebraic expression, now even right away, people, like I'm going to sort of like compare the word expression with the word equation, So down here, I'll even write it down already. Like an equation is a mathematical sentence that uses a what? Like how do you know, like what really makes an equation an equation? Think about that for a couple seconds. A math that uses an equal sign. Maybe you were able to think about. So that's like an equation, but an expression is like kind of like that same thing. It's a mathematical phrase. It just doesn't have an equal sign. But it does include, it can include numbers, variables, and operation symbols. All right? I mean, that's just what can make an expression, Now, I'm going to emphasize the word can. It can include numbers, variables, and operation symbols. Because honestly, an expression could only involve a number. It's kind of a weak expression, but like if I just said 5, just a number, that's an expression technically, An expression can only include a variable like x, like that's an expression on its own. I mean, it's kind of a weak one, but I mean but usually when you think of an expression, you think of like you put all of this together, like 5x minus 7, or 4x squared minus 3x plus 8. I don't know, just kind of randomly. Who goes there? Jack? Better late than never, I guess. But anyway, moving on. Here's something you got to be kind of good at, going into like this lesson in this chapter. Write an expression that basically says like these phrases. So 3 more than x. How could you write like a mathematical expression, a mathematical little sentence that pretty much says the same as 3 more than x? Jack, what do you think? Throwing you right into the deep end here, Jack.
No.
X plus 3. Okay? So this is basically saying in math of like 3 more than x. Like think about that. If I have $3 more than Jack, hey Jack, I have $3 more than you. Then you just take whatever Jack has and you add 3 to it, and that's me. You know what I mean? I have $3 more. So that's like an addition sort of vibe. You know what I mean? What does the word product mean? Remember the word product? That means multiplication. So the product of 7 and some number, well, we're just going to have to use a variable for like just some number. So like you could say 7x or 7n or whatever variable you want. But the product means multiplication. Okay? Let's see here. Connor, do you know what the word sum means? If you were like translate.
It's when you add 2 things together. I don't remember exactly what it meant though.
No, that's it. That's what it means. Good job. Like if I were to say, because I think this might pop up on your homework and stuff, the sum of like 5 and some number, you would say like 5 plus n. It's the answer to an addition problem. Like obviously n minus 6. Well, that's probably the easiest one on here. N minus 6. Doy. You know what I mean? Oh, number 4. Oh boy. 9. So everyone look at this one very carefully. This is maybe the toughest one. 9 less than 2 times a number. Well, first of all, 2 times a number, we'll just call that like 2n, you know? So 2 times a number, that's 2n, obviously, right? 2 times n. 2 times something, x or m or whatever. I'm just using n. 9 less than that, okay? So we're not going to use, in this context, we're not going to use a less than symbol, because that's just not what's going on here, you know? It's kind of like the opposite of more than, you know? If I have $9 less than what Jack has, think about that. I have $9 less than what Jack has. Like, wouldn't you take whatever Jack has and subtract 9 from that? So here we go. In this situation, less than means we're going to subtract. But listen to this. It's not accurate to say 9 minus 2n. That's not how it works, you know. If I have $9 less than Jack, I'm not going to do 9 minus whatever Jack has. It's got to be whatever minus 9. So this is the answer to this number 4. 2n minus 9 is 9 less than that, okay? The difference, that means subtraction also. So t minus 8, that's what the word different means. And then the quotient, Aaron, if you could unmute, do you know what the word quotient applies to?
Division.
Very good. So we have the quotient of this. Oh, here's the word sum. I guess it is here. So the quotient of this and this sum. So it's like, this is like, you know, y plus 5. But overall here, people, the quotient of 12 and that sum, I suppose you could write it a couple different ways. You could do 12 divided by this sum, but you're going to want to put it in parentheses. You know what I mean? Or you could have just made this into a fraction, you know, because division could be written as a fraction. Like you could have written 12 over y plus 5 as like a fraction. So maybe I'll even write that down. Or, you know, because this is correct. Or 12 over y plus 5, okay? And then, of course, if we're going to actually make it into like not just an expression, but an equation, then now there's got to be an equal sign in there. All right, let's really get down to business. These were just like, you know, baby steps, I don't know, for lack of a better word, and like, you know, sum and quotient and product and all this kind of stuff. Let's do some real math, okay? Here we go. Suppose the manager at Best Buy raises the price of CDs, man, who buys CDs anymore, to $15. Write an equation for the cost of n CDs. Then complete the table. I mean, I don't think we have to do it like necessarily in that order. You know, if the price of CDs is $15, we could probably fill out the table first. You know, it doesn't really matter. So $15 a pop. Well, that means one CD would be $15, right? 2 CDs would be $30. But wait, 3 CDs, $45, right? Oh, but what about 5 CDs? Oh, wait a minute. So 15, 30, 45. Not 60, but 75? 10 CDs. Wow. At $15 a pop, it looks like that's going to be $150. Who actually knows? Feel free to unmute and speak up for some glory here. Does anyone actually know what the equation would be? Ooh, here we go.
15n.
Yeah. I like that. Who was that? Connor? Okay. Basically, it's not the full answer, okay, because we want an equation. So this would be like a pretty good expression, but if we wanted to actually make it a full equation, we would just need to say like, I don't know, the cost, okay? So let's say like C. That's it. So all it takes is that to turn like this expression and turn into like a full equation, okay? So yeah, n. See, this is what I meant with like up here. A variable can like be open-ended. It doesn't have to only represent one number. It could represent like any number you want. It could be like sort of like open-ended, you know what I mean? Because like the cost of like whatever number of CDs would be 15 times whatever, 15n. And so there's the equation. The cost would be 15 times whatever, And so this cost variable is like open-ended, It depends on the number of CDs. Anyway, let's do the back really quick. Here we go. The total charge is the number of miles times 21 cents, or $0.21. Okay, again, like that, hopefully that doesn't confuse you, okay? Just talking about, well, this is 21 cents. You could also say it's $0.21. Anyway, so the total charge is the number of miles times 21 cents combined with $145 insurance. So this is probably like renting a car, and like, hey, I know like when I'm traveling with my father, I guess I've rented a car before. And yeah, like I always buy the insurance. It's probably like the way to go, like when you're renting a car. Because if you crash it, that could be like a lot of money you're going to owe somebody. So it's like getting the insurance is probably like just a pretty good idea, like when you're renting a car, you know what I mean? I know my father always gets like not only like the basic insurance, but like the full package insurance. It's just the way my father is. But anyway, so what would be like an equation here? And again, an equation, like we want an equation. I guess the direction should have said that. But so we're probably going to need like a couple of variables. So the total charge is one like varying unknown like quantity. So we could say that's going to be a variable, and you could use C, or you could use T, or you could use whatever variable you want. But let's see, I don't know, Dakaya, if total charge would be one varying, unknown or varying variable, what would be the other one? Do you know, Dakaya?
No, I don't know.
Okay, it would be like the number of miles. So the two things that can vary, that could be like a lot of different numbers, like we don't know the number of miles, and therefore we don't know the total charge. So these are the two things that are going to be like our variables in the equation. You know what I mean? And seeing as how, here's something to kind of catch on to if you can, hopefully, right? Pretty quick. If you can sort of point out like which one's going to be like the more dependent one, that's going to be like what's going to be over here on the left. So like I would think that the total charge would depend on how many miles. So I'm going to put the C variable over here, and it's going to equal blah, 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 blah. All right, so here's where all this other information comes into play. The total charge is going to be like whatever the miles is. And again, for now, we just have to call it M, because it can vary. Get it? It can vary. It's a variable. See, how that works? It's the number of variables times 0.21. Well, that's easy. 0.21 times whatever. Whatever the miles is, we just have to call it M. Combined with the one-time fee of $145 insurance, well, that's just going to get tacked on. So doesn't this pretty much describe our total cost? It's going to be 0.21 times whatever the miles is, plus that one-time cost of the insurance, so you don't end up paying like $1,000 when you crash the car. You know what I mean? So that's that example. The next example, see again, we're going to be writing an equation. So again, like what are our, well, here it's kind of obvious, you know what I mean? Like it's pretty much no secret what our two varying quantities are. We got cost of purchase and we have the change from 20 bucks. So whatever your cost was of whatever you're buying, and then over here, you know, like if you give them a $20 bill, what your change is. So we have two columns. There's your two variables. Okay. Now here, we could use P or C or I don't know. We could use whatever letter you want. But you know what? People, how about this? Seeing as how X and Y are probably the most common variables you're ever going to use, let's use X and Y here, you know. And speaking of what's dependent and what's independent, you know, usually the second column is like more dependent, you know, which is going to be like your whatever equals, okay? So, if anyone wants to unmute and speak up, looking at all this information in the table, you know, like here, if X was 20, then obviously the change, like if something costs $20, you're not going to get anything in change. If something costs $19 and you give a $20 bill, they're going to give you $1 back in change. If something is $17.50, you're going to get that much in change. If something is $11.59, you're going to get that much in change if you give them a $20 bill. Anyway, so what describes, like, you know, this relationship? Like if this was X, then so what does Y equal? You know what I mean? What is Y always going to equal? You know, like what's the relationship between 20 and 0, 19 and 1, 1750 and 250? Like what's that relationship? You know what I mean? Let's see, let me think about this. Isn't Y always going to equal the $20 bill minus whatever the purchase was? I think that'll work, right? Oh my gosh. Second day in a row. One second, gang. Please think about that for a minute. I got to get my door quick. Hey, man. Just come in and close the door. All right, so hopefully, gang, that makes sense because, again, we're just trying to come up with an equation that describes the relationship between, you know, the cost of something and the change you get from a $20 bill. You know what I mean? Like this is always going to be if this is the change, you know, you get the change by doing 20 minus whatever the cost was. And it works with this pairing. So this is maybe the other thing I want to emphasize here on this one. It works for like this X with that Y. It works for this X with this Y combo. You know, all of these pairs hold true with this equation where the Y will always equal 20 minus whatever the X was. A couple more examples in the last couple minutes here. So again here, we could say X and Y, or it's always up to you. Again, X and Y are very common. Or we could say, I don't know, E for earned and S for saved. Just don't make your S's look like 5s. Okay, so here we go. Again, the second column is usually your more dependent column, which means it's going to be like, okay, amount saved will always equal whatever, depending on E. Okay, so what do you guys think the relationship is between each amount earned? So if the amount earned is 15 and $7.50, $20, $10, $25, $12.50, and then this ugly one. But, you know, the first three are a little bit easier to kind of look at, like 20 and 10. what is the relationship here between the amount earned and the amount saved? Does anybody know? Do you guys see that, like, the amount saved is always whatever this number is divided by 2? Right? You take the amount earned, you divide it by 2, and you get S. Take the amount earned, divide it by 2, you get that. Take that, you divide it by 2, and you get that. You take this, and you divide it by 2. Actually, do you? What the? Wait a second. Hold on a second. This doesn't make any sense right here. Let's cross that out, man. What? I don't even know what was going on there. Probably my fault. But yeah, take a look. See, 15 and 750 divide by 2, divide by 2. So here we go. The amount saved will always be whatever E is divided by 2. So that's that equation. Okay? Last example. U-Haul charges a flat, another one of these, huh? U-Haul charges a flat rate of $25. So this is a flat rate. Flat rate of $25 to rent a moving truck. Upon return, you must pay 40 cents, or in other words, $0.40 for every mile you drove. Write an equation for the total cost, just based on the flat rate and, not necessarily, like, you had to pay to fill up the gas tank, whatever. But, what's this going to be? So let's say total cost, we'll say, is T for total cost. And the other unknown variable, I think, is like the number of miles, M. So this one actually is just like this one. So apparently, right, if you're paying 40 cents for every mile, it makes sense to multiply. This is a classic situation where you're going to have to multiply. 40 cents for every mile. Well, that means you're going to take whatever the number of miles was, which is M, and you're going to multiply it with 0.40. So that's going to be a multiplication in your equation. And then this like one-time flat rate of 25, that's just going to be like added to that, and that's what's going to equal your total charge. Okay? So that's the kind of stuff you're going to what a lot of you need to do is you got to do that test first, your unit. So Jack, you came in a little late, and William, I don't know, and Hannah, I don't know if you saw me point out that, like, hey, you got it. This is massively important that you guys get this Unit 1 test done. But other than that, you got this homework also on your plate, kind of now. And so this stuff. So again, just an expression. Just an expression. But then here, an equation, using two variables of your choosing. You know what I mean? You might want to maybe write that in, because there's going to be probably a couple of variables when you write an actual full equation, okay? Again, write an equation. Variable number 1, variable number 2. And then at the end, you're back to just writing an expression, okay? If you have any questions, then you can